Let's talk about randomization. How does a study go from a large population to two separate but similar groups? The goal of randomization is to achieve balance between the groups in a clinical trial. This allows investigators to control for known confounding variables as well as unknown confounding variables. Remember, a confounding variable is a type of extraneous variable that is related to the study's independent and dependent variables. Confounders are an unmeasured third variable that influences both the cause and the effect. In a study, we are trying to prove that the independent variables cause the dependent variables. If we don't control for confounding variables, we can draw erroneous conclusions. Randomization is one way we can control for confounders. If done correctly, randomization will spread the confounding variables evenly between the groups. Let's talk about types of randomization. There are three main types of randomization you will encounter in clinical trials. They are simple, blocked, and stratified. We'll start with simple randomization. Simple randomization is the most basic form of randomization. It can be accomplished by flipping a coin, a 1-to-1 ratio, or random number tables. This is a weaker form of randomization because it doesn't account for confounders, which may end up not being evenly distributed among the groups. In blocked randomization, participants are randomized within blocks to make sure equal numbers of participants are assigned to each group. For example, let's say there is a study comparing treatment A to treatment B, and the investigators are planning to randomize the participants in groups of 6. For block 1, the sequence is A, B, A, B, B. As participant 1 comes into the study, she is randomized to treatment A. Participant 2 is randomized to treatment B, participant 3 to treatment A, participant 4 to treatment A, and so on until the block is complete. For block 2, the randomization sequence is changed. The block order is now B, B, A, B, A. And participants in block 2 are randomized according to this sequence. A key advantage of block randomization is that treatment groups will be equal in size and will tend to have uniform distribution of confounders. With stratified randomization, participants from a population are grouped into strata based on a clinical feature that can influence or confound the outcome. Example strata include smoking status, a particular age cutoff, or duration of a disease such as diabetes. Participants are then randomized from each strata into the intervention or control group. This will ensure that the confounding variables are evenly distributed between the groups. Oftentimes, a clinical trial will combine randomization strategies, as was done here in this trial published in the New England Journal of Medicine. It is our job as the reader to determine how randomization was accomplished and if there is a potential for bias with the randomization scheme. Thank you for watching. I hope this helps your understanding of randomization.